Hello everyone, this is Mr. Kozlowski. Welcome to Unit 4, Lecture number 2 for Learning Target number 2. And today we're going to be talking about the law of conservation of energy. With the law of conservation of energy, basically students are going to have to relate energy conversions and understand that energy is conserved. And they must apply this to common occurrences in the everyday world. You must understand that energy is transferred, it's never lost within a system, and therefore what has developed in science is this law of conservation of energy. So how is energy conserved? What do we need to know about it? And how can we apply it to everyday occurrences in the world? Well, very simply put, that energy is never lost within a system. It simply changes forms. And when we change forms, it's basically converted into that other type of energy. So if we look here, we have a roller coaster, and the picture basically states that as a coaster car loses height, it gains speed. And PE, which is potential energy, is going to be transferred into kinetic energy. As the coaster gains height, it loses speed. Therefore, the kinetic energy is going to be transferred into potential energy. And the sum of these two energies, kinetic energy and potential energy, well, that's going to be constant because that energy is conserved. So basically put, if we look here, we have the coaster at this height, we have high potential energy, low kinetic energy, because let's say it's standing still right here. It's not moving, it doesn't have any kinetic energy, but it is at a specific height. It has high potential energy in comparison to down here. Down at the bottom of this slope, we have minimum potential energy, but we assume it's moving at high speed, therefore it's got its maximum kinetic energy. And then if it goes over this little hump in the roller coaster, we have obviously some potential energy there, a very small amount, with more high kinetic energy. The thing about potential energy and kinetic energy in this example is that when we add the two together, the amount of energy is always going to be the same or equal. It's never lost, assuming that the environment is frictionless and energy transfers are complete. This we know as the law of conservation of energy. The law of conservation of energy simply states that when energy is converted from one form to another, the total amount of energy does not change. You probably have heard this phrase that energy cannot be created nor destroyed. That's essentially the law of conservation of energy. That energy is not destroyed, it's not created, it simply is transferred and changes forms. So how does that look from what we need to do furthermore in class? Well, this is going to give you a preview of actually Learning Target 3, and we're going to go over these more in depth in Learning Target 3 video. But basically what you have to do to signify this is make an energy barograph, or what we call an LOL diagram, laugh out loud diagram. LOL stands for, if you look here at this picture, we have the bar graph here. The axes would make an L. Explain the difference part would be the O, and then obviously we have another L here with the graph axes. We actually have a diagram that goes L, O, L, O, L. Now, for our purposes, just to understand the law of conservation of energy, we're going to essentially cross out this portion right here. Explain the difference. I am not concerned right now about the difference, and we are going to assume that there's no friction at all, and that means there's going to be a complete energy transfer. So if we use this example here, we have a toy car sits at the top of a ramp. So let's say that we have 1, 2, 3, 4 bars of energy here when the car is sitting on top of a ramp. Well, the type of energy that we have is gravitational potential energy. And we know that if energy changes forms and sum of all energy is going to equal the sum at the beginning and is going to be equal to the end. Well, here we know that this is all gravitational potential energy. So we can draw this graph here, and we signify the different types of energy. So if we look, this is all gravitational potential. There's no elastic, there's no kinetic. Now the car moves halfway down. And assuming that the car moves halfway down the ramp, we know that it's going to be moving. Well, our total energy in the law of conservation of energy says that energy is conserved. It simply transfers and changes forms. We know that the total is still going to be 4 bars here of energy. Again, we are assuming that there's no friction here, so the energy transfer is complete. Well, if it's halfway down, well, half of 4 bars is going to be 2 bars. So we know that gravitational potential energy is going to be 2 bars. And we assume that the car is moving of some sort, and assuming it's halfway down, we're going to have some kinetic energy, and that's going to be half as well. And we're going to have 2 bars there as well to fill in our energy bar graph. If we keep going, let's say the car is now at the bottom of the ramp and it's driving on a flat table. We're assuming that now there's no gravitational potential energy, but we still have, again, 4 bars of total energy here because energy is conserved. Law of conservation of energy basically states that the sum of all energies is going to equal because energy simply changes forms. Well, where does the if there's no gravitational energy, well, we're assuming that it's moving at the bottom of the ramp. All that is then converted into kinetic energy. We draw our graph, and that's what it will look like. So as you can see, through these 3 different types of motions in this event, we are modeling the types of energy that are existent at different points. The total energy throughout that whole transfer of energy never changes. It always stays the same. So you can see that energy simply changes forms. That is the law of conservation of energy. So in terms of what you're going to need to know for learning target number 2, again, students, you have to be able to explain the law of conservation of energy conceptually. So if I go back to this slide here, you have to just, again, relatively speaking, all right, we have high potential energy, low kinetic. Well, we have low potential over here, high kinetic. Well, the total amount of energy from beginning to end must equal each other. The second thing that you're going to have to know is you're going to have to be able to accurately complete energy bar graphs. For right now, that's this skill. The car sits at top of the ramp, the car moves halfway down the ramp, etc. You're going to have to fill out these energy bar graphs for each one of those events throughout the motion event. Do not worry about the explain the difference part. That comes in learning target 3. So that's about it. If you have any questions on the law of conservation of energy, again, please feel free to contact me or ask questions during class. Again, the law is right here. And again, you must be able to explain that conceptually and fill out these bar graphs by the end of this learning target. So please let me know if you have any questions. Thanks.